All right, so now for part 3, we are in the process of trying to calculate our interval. We're going to take the difference of the sample means, plus or minus. We need the t critical value, and then we're going to multiply that by the standard error, which is the sample standard deviation squared divided by, that's n1. And then for the second sample, divided by that sample size as well. All right, so the values we have, the sample means are 3.2 and 2.0, plus or minus. Now, if I'm using the table for the t critical value, the two sample interval, the other thing I want to write down here, we are doing a 95% confidence interval. 95% confidence. So I'm going to show you the table here. So this is for the t distribution. Here's the t critical value. For 95%, 95% is going to be the middle part here, which means that on the left tail and the right tail would be 2.5% or 0.025 for that. Now the degrees of freedom, both of our samples are 10 students. Okay, so it doesn't matter which one we choose. We would take n minus 1, which would actually be 9. So take the 9. Now I'm going to go over to 0.025. That's the tail probability. That's each tail. Nicely, kind of a nice thing though, is actually at the bottom of the table, it writes down confidence level C. So it might be easier just to say, hey, there's the 95% confidence, and now I come up, and it's 2.262 is going to be my t critical value, 2.262. So let me come back to the paper here. .262 times the square root, and we take our sample standard deviations. So for the caffeine, that was 2.6998 squared divided by the sample size, which is 10, not 10 squared, just 10, plus the standard deviation for the second sample was 2.6247 squared divided by 10. I would recommend using the calculator just because, again, there's a lot of stuff going on here, a lot of ways for me to make a mistake. But now if I type this, the 3.2 minus the 2.0, that's 1.2. I'll do minus first. 2.262 times the square root. This is my standard error. 2.6998 squared over 10 plus fraction 2.6247 squared divided by 10 equals negative 1.493. So this is an interval negative 1.493. And then if I take this, and now I need to do addition, come all the way over, 1.2 plus, because it was plus or minus. So we went to the left, that's the left bound, we need the right bound, which is 3.893. Okay, this is our confidence interval if we work this by hand. Now the last thing we need to do, panic, P-A-N-I-C, we need to make our conclusion. So we are going to say we are 95% confident that the interval from negative 1.493 to 3.893 captures the true. Okay, now this is the true difference in means, or the way that they phrased it in the problem, they said the true difference in true means. I think that's kind of repetitive, but I'll go ahead and write it. The true difference in two means, in true mean change, in pulse rates, which is caffeine minus no caffeine. We are 95% confident that the interval from negative 1.493 to positive 3.893 captures the true difference in true mean change in pulse rates. Okay, now the last thing that we'll do here, if I had used the calculator to do the whole thing, so if I had gone stat test, now this is an interval, I'm looking for a 2-sample t interval. Now again, you got to be careful with the TI because for the proportions, we did a 2-proportion z interval, but when I go for t, it's a 2-sample t interval. If I do have my data like this, if I've already typed it into list 1 and list 2, I can go ahead and just go with this. The confidence level is 0.95. We're not pooling anything, we just calculate. And you'll notice that this is actually kind of different from what we got with doing it by hand. We had negative 1.302, where we had gotten negative 1.493, and then the upper bound was 3.70, and this was 3.893. So the calculator is different. Notice that the degrees of freedom is quite different. Okay, 17, they used 17.98, we had used 9. That's why we're getting a little bit different intervals here. If you do use the calculator, make sure you're writing down your sample means, your sample standard deviation, your degrees of freedom for all of that, okay? And the very last thing here, notice that our interval is negative as well. It goes from negative numbers to positive numbers. So is there convincing evidence that there is a true difference in the mean change in pulse rates? Well, since 0 is part of this interval, we'd have to say we don't have convincing evidence that there's going to be a true difference in means whether they're taking caffeine or not caffeine, because 0 is a plausible value. So if you were asked, we would say there is not convincing evidence that the pulse rate from caffeine is higher than the pulse rate, and we're talking about change, the pulse rate change. The pulse rate change from caffeine is higher than the pulse rate caffeine, or change from not caffeine, from not drinking caffeine. Even though in our sample, yes, the mean change here, 3.2, is certainly higher than 2.0, and the difference between these is positive, since the interval also has negative values and 0 is plausible, okay, we would say 0 is plausible because it's in the interval. It is plausible that the true mean difference in pulse rates is 0. In other words, there's no difference caused by the caffeine versus non-caffeine. And that is the end of part 3.